We are going to talk about the symbols used for circuit diagrams, and we want to be able to create a written model to represent the motion of an electron in a circuit by the end of today. So there are some various symbols. All of the symbols are on your reference table. So you have an electric cell. This means a battery. The positive end is the long line and the negative end is the short line. A battery is a series of cells. So an electric cell is just one, but a battery has many of them. So in our schematics, we're going to be following the electrons so that they come out of the negative and into the positive. So they are going to be kind of weird that way, but that's how it's drawn. And so that's what happens. So they are coming out of the negative into the positive. So here's a switch. The switch gives control over whether the current will flow or not. If it's open, there's a break in the circuit. If it's closed, there's a continuous path. A resistor, as we talked about before, it controls how much current flows. And it just looks like a jagged line here. All of the following are resistors, like lights, resistors, even the wire causes resistance. And it's measured in ohms. In a schematic, wires have zero resistance. That's an ideal. It's physics world. So this is just a quick joke. This is what a resistor looks like. You'll be seeing those later. It says ohm. Okay, anyway. So a variable resistor has this little line above it. It just means that you can change how much resistance is being given to the circuit at that time. It's also called a rheostat, and like a dimmer switch on a light or the volume on some stereos works with a variable resistor. A voltmeter measures the potential difference, the voltage drop from one side to the other, and it's connected in parallel. We'll talk about this later. And it has a high resistance so that the majority of the current flows through the other branch of the parallel circuit. You have to in order to measure the voltage. So an ammeter actually measures the current through the circuit, so it has to be in the circuit, and we'll talk about this a little bit later. It has a low resistance to allow electrons to freely pass through, and it's connected in series. It's measured in amps. So there are two types of circuits. Series circuits are along a straight line. So you could have your battery, and then you have a resistor, and then it comes back like that. So it has one path like this, and this is series. So a typical example, these are old Christmas lights. I don't think they do this anymore. But if you took out one light, then the light acts as a resistor, as a resistor. So if you took it out, then that means that there's a break. So if you took it out, then the current couldn't flow. And then the Christmas lights didn't work anymore, and you had to find out which one didn't work. Parallel has choices of which path to follow. Current will follow the path of least resistance, and all branches have the same potential difference, like home lighting. So again, we have our circuit. And it can be any shape like that, but if you have another path like this, where you have this and this is parallel. It's kind of messy. We'll see more in class. Okay, so the ammeter placement must be put on the circuit to measure current. while voltmeters are placed across a circuit. So this is here and this is here. This is parallel with the circuit in question. This right here is the circuit. This is the voltmeter. And it's measuring the voltage across this resistor. Voltmeters placed in parallel, placed across the resistor, across the circuit.